we are going to be integrating with respect to a different variable. So I want you to pay attention to the variable of integration. All the others are going to be constant, and this is very similar sort of thinking to how we calculated our partial derivatives. Example 1. The integral from 1 to 2y of 2xy dx. Notice that the variable of integration is dx, so we really only need to focus on the x. The y is going to be constant. So the integral of a 2x dx will be x squared. Keep the y in there, and then it's going to be from 1 to 2y. And when you plug these in, again, pay attention to the variable of integration. So x is going to be 2y, and x is going to be 1 are the values that we're going to be plugging in. So I have 2y quantity squared times y minus 1 squared times y, and I get 4y cubed minus y. Try another one. The integral from 1 to x of 2x squared over y squared plus 2y dy. Now this time our variable of integration is y, so pay attention to the y's. Everything else is constant. So the integral of a 2x squared over y squared, the integral of 1 over y squared, is going to give us negative 1 over y. I need to write in my constants, which are 2x squared. And the second part of this, the integral of 2y with respect to y, is going to be y squared. And y is going to go from 1 to x. So again here, pay attention that we're going to be plugging those values in for y. So when we do that, we have negative 2x squared over x plus x squared minus negative 2x squared plus 1. So simplifying this, I get negative 2x plus x squared plus 2x squared minus 1, which is 3x squared minus 2x minus 1. One more example. The integral from y to 2y of x squared plus y squared dx. So when we integrate x squared, we get 1/3 x cubed. And over here, we just have xy squared. So we're going to be plugging in x equals y to x equals to 2y. And we have 1/3 times 2y cubed plus 2y times y squared minus 1/3 y cubed plus y cubed. So we need to simplify all of this stuff. And over here on the right-hand side, we have 4/3 y cubed. Adding all these up, you're going to get 10y cubed over 3. Now all of this stuff is going to lead up to what we call iterated integrals. An iterated integral is a type of definite integral where the integrand is also an integral. So an example of that would be something like this. The integral from 1 to 2 of the integral from 1 to x of some function f of xy dy dx. Now how I'd like for you to look at this and interpret this is by paying attention to the bounds. So if you look at the inside integral, which is the integrand of our problem, it's with respect to y, so that tells us that our y value is bounded between 1 and x. When you look at the outside integral, which is with respect to x, that's bounded between 1 and 2. So from this, we can actually see the region on the xy plane where x is between 1 and 2, so that means you have these two vertical lines, and y is greater than or equal to 1 is a horizontal line at 1, and y equals to 1 is a diagonal line, and since y is bounded between those and x is bounded between the other two pieces, this is the region that we have. So what's happening here in our multivariable calculus is that we are going to end up finding this area, or the volume of a region, with that as its base shape. I could switch this integral around, and it would read the integral from 1 to 2 of the integral from y to 2 of f of xy dx dy. Now let's take a look at this same graph with the same boundaries drawn in, and if we think about this region, this little triangular region, but we now have horizontal sections, notice what is our left-hand boundary. It's the line y equals to x, or x equals to y. The right-hand boundary is the line x equals to 2. So if you look right in here, notice x is between 2 and y. And where are we summing up all of these horizontal pieces? The lowest of which is going to be at y equals to 1, and the highest of which is going to be at y equals to 2, which is why we have as our outside boundary y is between 1 and 2. So we're going to be working more on these with the bounds, but for now we're just going to practice integrating these iterated integrals. So let's take a look at this one. The integral from 1 to 2 of the integral from 1 to x of 2x squared over y squared plus 2y dy dx. Now this inside integral here is the one that we did previously. Integrating that gives me negative 2x squared over y plus y squared from 1 to x dx. From our example 2 above, we came up with 3x squared minus 2x minus 1. And from this point on, it becomes just like what you're used to, a regular integral, where this is x cubed minus x squared minus x from 1 to 2. And we just plug in our 2 and plug in our 1. And we get 3. So one last one, the integral from negative 1 to 1, the integral from negative 2 to 2 of x squared minus y squared dy dx. So focusing on the inside integral, integrating with respect to y gives us x squared y minus 1/3 y cubed from negative 2 to 2 dx. Now again, my suggestion for you guys here while you're still kind of learning this stuff is to make sure you are clear here, and let's write out y equals negative 2 to y equals to positive 2, because a real common mistake is to plug those numbers in for the wrong thing. So here we'll have 2x squared minus 8 over 3 minus, and now we got to plug in the negative 2, so we have negative 2x squared plus 8 over 3 dx. So we're still not done integrating. Let's add these things up. We have 4x squared minus 16/3, which is going to be 4/3 x cubed minus 16/3 x from negative 1 to 1. And I know that you guys can all do this part easily. This answer is going to come out to be negative 8.